Look, you're holding a diamond ring, thinking you got the hardest forever solid in the universe. But here's the thing, you're actually holding a supercooled ghost. Every single carbon atom in that rock is screaming to get out. In the world of thermodynamics, a diamond isn't a stable end state. It's a transient phase. It's a liquid that has been frozen in a state of metastability for 1 billion years. Given enough time, that diamond doesn't stay a diamond. It flows back into graphite. Think about a ball on a shelf. It looks perfectly still, right? But it has potential energy. It wants to fall to the floor. A diamond is that ball. The floor is graphite, the soft gray stuff in your pencil. Under the normal pressure of the Earth's surface, carbon prefers to be flat sheets. To make a diamond, you have to crush carbon under 15 gigapascals of pressure. You're loading the spring. When you bring it to the surface, the spring stays compressed because the nothing around it is too weak to let it snap back. You got to understand, this is a causal delay. We call it the kinetic barrier. To turn into graphite, the carbon atoms have to rearrange themselves. They have to break their tetrahedral bonds and flatten out. But at room temperature, they don't have the thermal energy to make the jump. They are trapped in a diamond shape. It's like a crowd of people packed so tightly into a room that no one can move toward the exit. Why is this a liquid? Because if you heat that diamond up to 2000 degrees, the vibration of the atoms finally overcomes the barrier. The diamond doesn't just melt, it sublimes into graphite right before your eyes. It flows into its true identity. You aren't wearing a rock. You are wearing a kinetic standoff that is billions of years old, and the only reason diamonds are forever is that the universe is currently too cold to let the liquid move. You got to understand that a solid is just a liquid that hasn't found its way home yet. In a diamond, every carbon atom is locked into a tetrahedral lattice. It's a three-dimensional cage where every atom is bonded to 4 others with a force so massive it defies human intuition. We call this a covalent bond. It's the strongest glue in chemistry. But here's the thing, that glue is under a false equilibrium. Think about a mountainside. At the top, you have the diamond. At the bottom, you have the graphite. To get to the bottom, the atoms have to roll down the hill. But in between them is a massive wall of energy. We call this the activation energy. At room temperature, the atoms are vibrating, but they don't have enough kinetic energy to hop over the wall. They're frozen in place, like a line of cars at a red light that never turns green. Why is this a liquid problem? Because if you look at the mean free path of a carbon atom, it's effectively 0. It's trapped in a pot of its own making. But the laws of entropy are always pulling at it. Entropy wants the carbon to be in the lowest energy state possible. And at the surface of the Earth, that state is graphite. A diamond is a now that refuses to become a then. It's a causal standoff that is billions of years old. Look, here is the real twist. If you wait long enough, we're talking trillions of years, those atoms will eventually tunnel through the wall. We've talked about quantum tunneling before. It's the ghost in the machine. One by one, the carbon atoms will slip out of their cages and flatten into sheets. Your forever rock is slowly and visibly flowing into a pile of gray dust. We aren't just solid. We're a statistical pause in a universe that is trying to melt everything back into its simplest form. And we're just the ones holding the watch. Look, to understand why a diamond is a liquid, you have to look at where it was born. Deep in the Earth's mantle, about 100 miles down, the temperature is 2,000 degrees and the pressure is 5 million pounds per square inch. At those depths, carbon isn't a rock. It's a supercritical fluid. It's a roiling, high-density soup that behaves like a liquid but has the density of a solid. We call this the carbon phase boundary. Think about a pressure cooker. When you turn the heat up, the water doesn't just boil, it becomes aggressive. Inside the Earth, carbon atoms are slamming into each other with so much kinetic energy that they can't form a stable lattice. They are flowing through the molten rock like a ghost. But when a volcanic eruption, what we call a kimberlite pipe, blasts that soup toward the surface in a supersonic burp, the temperature drops faster than the pressure can relax. You gotta understand, this is a thermal quench. The carbon atoms are moving so fast that when the cold of the upper crust hits them, they get flash frozen into whatever shape they were in at that exact microsecond. They wanted to be a liquid, but they got caught in a tetrahedral trap. We call this a vitreous state. It's the same way glass is made. It's a liquid that forgot how to flow because the universe pulled the rug out from under its feet. Why is this a causal freeze? Because the diamond is a memory of the deep earth. It's a piece of the mantle that is stuck in the wrong neighborhood. If you took a diamond back down to its home, it would melt into that soup in a heartbeat. We are living in a now where the solid objects around us are just delayed liquids. We aren't just matter, we're a geological snapshot that has been preserved by the cold. And we're just the ones admiring the ice before it eventually turns back into water. You gotta understand that the forever part of a diamond is a lie told by a clock that is ticking too slowly for us to hear. In the world of statistical mechanics, everything is a tumble toward the state of highest disorder. We call this the second law of thermodynamics. For a bunch of carbon atoms, the state of highest entropy isn't a rigid, perfect crystal. It's a messy, layered pile of graphite. The diamond is a low entropy anomaly that is trying to evaporate into the vacuum. Think about a sandcastle on a beach. It looks solid, it has a shape, and it's held together by the glue of wet sand. But the moment the water starts to dry, the glue fails. The sandcastle doesn't break, it flows back into a pile of sand. A diamond is a sandcastle built of carbon-12. It's a highly ordered structure that is constantly being bombarded by thermal vibrations and cosmic rays. Every hit is a tiny nudge toward the exit. Why is this a causal decay? Because the solid we see is just a time-averaged delusion. If you could watch a diamond for 1 billion trillion years, you would see the atoms hopping from one site to another. You'd see the sharp edges of the crystal start to round off, and the clear structure start to cloud over. It's a kinetic migration. We call this solid-state diffusion. It's the same process that makes a piece of lead and a piece of gold eventually bleed into each other if you leave them touching for a century. Look, here is the real kicker. We are living in a now where the universe is still young enough to have frozen liquids like diamonds. But as the stars burn out and the temperature of the vacuum drops even further, the ticking of the entropy clock is the only thing left. We aren't just matter, we're a transient order in a sea of chaos. We are the ice that thinks it's a rock. And we're just the ones admiring the freeze before the heat of the universe eventually pays its debt. Look, if you really want to win an argument with a jeweler, you have to talk about the amorphous nature of solids. In physics, we often group diamonds with things like window glass or obsidian. Why? Because they are all non-equilibrium solids. They are liquids that have been arrested in their movement. A diamond has a crystal structure, sure, but that structure is a mistake that the universe made while cooling down too fast. It's a kinetic lock-in. Think about a game of musical chairs. When the music is playing, the carbon atoms are a liquid. They're moving, flowing, and shifting. But when the thermal music stops abruptly, everyone has to sit down in the nearest chair. If the atoms sit down in a perfect grid, you get a diamond. If they sit down in a mess, you get amorphous carbon. But in both cases, they are just sitting because they don't have the energy to stand up again. They are a frozen flow. You got to understand, this is a causal trap. We call this the glass transition. It's the point where the viscosity of a substance becomes so high that it behaves like a solid on a human timescale. For a diamond, that viscosity is essentially infinite. It would take longer than the age of the universe for a diamond to slump under its own weight, like a piece of warm pitch. But mathematically, it's still a viscous liquid. It has a flow rate that isn't zero. It's near zero. Why is this a liquid problem? Because it means that hardness is a relative term. A diamond is only hard because its atoms are stuck in a high-energy configuration. If you hit it with a hammer, it doesn't melt, it shatters. It fails because it's brittle. It can't flow to absorb the impact. It's a brittle liquid. We are living in a now where we've built our world out of these frozen states. We aren't just matter, we're a dynamic standoff, and we're just the ones holding the glass before it eventually remembers how to move. You got to understand that the identity of an atom is a slave to the environment it lives in. In physics, we use a phase diagram to map out where a substance is a solid, a liquid, or a gas. For carbon, the map is a wild landscape of extreme pressures and temperatures. There is a specific point on that map, the triple point, where carbon can exist as a solid, a liquid, and a gas all at the same time. But a diamond, it's sitting in a forbidden zone on that map. Think about a border crossing To get from the diamond territory to the graphite territory, you have to cross a line of phase transition. At the Earth's surface, we are deep inside the graphite zone. But because the carbon atoms are stuck in their tetrahedral grid, they can't see the border. They're like refugees who don't know the war is over. We call this a displacement barrier. It's a political map of the universe that says a diamond shouldn't exist where you're standing. Why is this a liquid problem? Because if you increase the pressure enough, like in the heart of a gas giant planet, the diamond doesn't just stay a rock. It actually becomes a metallic liquid. Scientists believe that on Uranus and Neptune, it literally rains diamonds. But as those diamonds sink toward the core, the heat and pressure become so intense that the grid dissolves. They become a molten carbon sea. We call this the high-pressure melt. Look, here is the real kicker. We've actually created this liquid diamond in a lab using shock compression. We hit a diamond with a laser so powerful, it turned it into a fluid in a billionth of a second. It didn't burn, it flowed. It's a kinetic reality check. We are living in a now, where the hardest thing we know is just one push away from being a puddle. We aren't just matter, we're a pressure-dependent illusion. And we're just the ones living on the thin ice of the crust, pretending the rocks are permanent. If you zoom in on the very edge of a diamond, the solid illusion starts to break down first. At the surface layer, the carbon atoms are in a state of constant dangling. They don't have 4 neighbors to bond with. They only have 3. This creates a massive surface energy imbalance. To the universe, the surface of a diamond is a liquid-like interface. It's a high-tension zone where the atoms are vibrating much faster than the ones in the middle. We call this surface permelting. Think about a drop of water on wax paper. The surface tension pulls it into a bead because it wants to be at the lowest energy state. On a diamond, the surface atoms are pulling inward, trying to find a way to rearrange. If you put a diamond in a vacuum and hit it with a beam of electrons, the surface layer will literally flow into a layer of graphite while the core stays hard. It's a causal shell. The liquid nature of the carbon is always trying to eat the crystal from the outside in. You gotta understand, this is why diamonds are so slippery to the touch. When you rub 2 diamonds together, you aren't just feeling hardness, you're feeling the low friction of a surface that is behaving like a high viscosity fluid. We call this tribology. In some industrial settings, we use diamond coatings not because they're strong, but because they act like a solid lubricant. They have a flow that is so thin it's measured in atoms. Why is this a liquid problem? Because it means that stability is a function of size. If you make a diamond small enough, we're talking a nanodiamond only a few atoms wide, it can't stay a solid. The surface energy becomes so dominant that the whole thing it relaxes into a buckyball or a tube. It melts into a new shape because it doesn't have enough bulk to keep the trap shut. We aren't just matter, we're a scale-dependent standoff. Here's the thing, if you want to understand the flow of a diamond, you have to look at the vibration of the lattice. In a perfect solid, the atoms would be still. But at any temperature above absolute zero, every carbon atom is shaking in its cage. We call these vibrations phonons. They are the sound of the crystal. If you could hear a diamond, it would be a scream of high-frequency energy. This shaking is the only thing keeping the carbon from being a static, dead object. Think about a stadium wave. The people aren't moving from their seats, but the wave is traveling through the crowd. In a diamond, the phonons are moving through the lattice at 12 kilometers per second. This is the speed of sound in the diamond. It's a kinetic transport that is so fast it makes the rock behave like a superfluid for heat. It's why a diamond feels cold to the touch. It's flowing the heat away from your finger faster than almost any other material on Earth. You gotta understand, this is a causal superhighway. We call this thermal conductivity. In most solids, heat moves like a crowd pushing through a doorway. But in a diamond, the grid is so stiff and the atoms are so light that the heat moves like a bullet. It's a kinetic transparency. We aren't just matter, we're a medium for energy to move through. A diamond isn't just sitting there, it's a flowing conductor of subatomic information. Why is this a liquid problem? Because if the phonons become too intense, the wave breaks the seats. The crystal melts from the inside out. We call this the Lindemann criterion. It's the vibrational limit where the solid can no longer hold its shape. We are living in a now where the ice is only stable because the music isn't loud enough to shake the walls down. We aren't just rocks. We're a symphony of motion that is one note away from becoming a puddle. Look, if you want to see the liquid in a diamond, you have to look for the mistakes. In a real diamond, there are point defects, missing atoms or impurities like nitrogen, snuck into the grid. These defects aren't static. They are crawling through the lattice like bubbles in a thick syrup. We call this atomic diffusion. Even at room temperature, a vacancy in the grid is hopping from one site to another, driven by the random kick of thermal fluctuations. Think about a slide puzzle. You can only move the squares because there is one empty space. That space is the liquid part of the puzzle. In a diamond, those empty spaces are vacancies. They allow the solid to have an internal flow that is invisible to the eye but measurable by a laser. If you heat a diamond up, the empty spaces move faster. They cluster together and change the color of the stone. We call this annealing. It's a subatomic reshuffling of the deck. You got to understand this is a causal drift. The diamond is healing or aging itself, one atom at a time. This flow is why we have blue or yellow diamonds. The impurities had to migrate through the hard rock to find their home. We call this the diffusion coefficient. It's a measure of how liquid a solid really is. For a diamond, that number is tiny, but it's not zero. It's a kinetic reality. Why is this a liquid problem? Because permanence is just a matter of observation time. If you lived for 1 billion years, a diamond would look like a slow-motion lava lamp. You'd see the colors shifting and flaws moving like clouds. We aren't just matter. We're a spatially locked fluid. We are the ice that is slowly, grain by grain, trying to remember how to be a stream. And we're just the ones living in the flash where it looks like a rock. Here's the thing. If you want to see a diamond actually flow like a river, you have to look at the giants of the solar system. Inside planets like Uranus and Neptune, the pressure is so high it crushes the atoms together until they lose their grid entirely. We call this the high-pressure melting point. In these extreme conditions, carbon becomes a metallic liquid. It's a dense, shiny fluid that can conduct electricity just like a wire. Think about a sponge. When you squeeze it in your hand, it stays solid. But if you put that sponge in a hydraulic press and apply 10 million pounds of force, the structure itself collapses. The air is squeezed out, and the solid begins to behave like a deformable mass. Inside a gas giant, the diamonds that rain from the sky eventually hit a layer where the heat and pressure are so high that they dissolve into a sea of liquid carbon. You got to understand, this is a causal transformation. The diamond is just a phase. It's a solid state that is bounded by the limits of the environment. If you change the environment, the rock vanishes. We call this structural phase transition. It's the same way ice becomes water, but on a scale that would crush a mountain into a pebble. We are living in a now where the hardness of a diamond is just a local rule. Why is this a liquid problem? Because it means that the solid universe is just a thin crust on top of a fluid reality. Most of the carbon in the universe isn't in a ring on someone's finger. It's in a molten sea at the heart of a planet. We aren't just matter. We're a pressure-dependent snapshot. We are the ice that thinks it's a rock because we've never seen the fire of the core. And we're just the ones living in the cold zone where the liquid has to hide inside a crystal. Look, if you watch a diamond for 1 billion years, you'll see it do something impossible. It'll start to deform. We think of diamonds as brittle. They shatter if you hit them with a hammer. But under the steady crushing weight of the Earth's crust, they behave like a plastic fluid. We call this dislocation creep. It's a flow that happens one atom at a time, where rows of carbon atoms slide past each other along specific planes in the crystal. Think about a deck of cards. If you push on the top card, the whole deck stays a solid block. But if you apply a constant massive pressure from the side, the cards will shift and slide over one another. That's a diamond in the mantle. The solid isn't moving as a whole. The internal layers are flowing. We call this plasticity. It's the same way a glacier flows down a mountain, even though it's made of solid ice. You gotta understand, this is a causal reorganization. This flow is the only reason we have rare pink diamonds. When the diamond is being shoved toward the surface, the sliding of the atoms creates glitches in the grid. These glitches absorb green light and reflect pink. We call this grain transformation. A pink diamond isn't a colored stone. It's a bruised liquid. It's a record of the stress the carbon felt as it tried to move. Why is this a liquid problem? Because it means that hardness is just a time-dependent friction. If you apply enough force for long enough, the grid becomes a river. We are living in a now where we've built our definitions of solid on a human lifespan. But to the Earth, a diamond is a viscous ribbon of carbon that is slowly being squeezed through the rock. We aren't just matter. We're a high-pressure flow that has been caught in a cold moment of time. And we're just the ones admiring the bruise before it eventually heals back into a puddle. If you take a diamond and put it in the empty space between the stars, it starts to do something impossible. It starts to evaporate. Even at absolute zero, the atoms at the surface of the diamond have a non-zero probability of jumping off the lattice and flying into the vacuum. We call this sublimation. It's the same way a block of dry ice turns into a gas. But for a diamond, the boiling point is so high that the process takes longer than the life of a sun. It's a kinetic leak. Think about a glass of water sitting on a table. If you leave it for a week, the water is gone. The fastest molecules hit the surface with enough kinetic energy to break the glue and escape. In a diamond, the glue is the covalent bond. It's a massive wall of energy, but the tail of the Maxwell-Boltzmann distribution says that there is always one atom that is moving fast enough to break the wall. It's a slow leak in the bucket of the universe. You gotta understand, this is a causal depletion. We call this the vapor pressure. For a diamond at room temperature, that pressure is so tiny that it would take 10 to the power 80 years for the diamond to vanish. That's a 1 followed by 80 zeros. But the nothing of the vacuum is a hungry beast. It is constantly pulling at the edges of the crystal. The diamond isn't a solid object, it's a vapor that hasn't realized it's allowed to leave yet. Why is this a liquid problem? Because it means that the solid state is only a temporal anchor. We are living in a now where the glue is strong enough to hold the wind in place. But in the long run, the wind always wins. Every diamond in the universe is a cloud that is waiting for the timer to run out. We aren't just matter. We're a subatomic evaporation that has been paused by the cold. And we're just the ones living in the cool of the evening before the mist eventually clears. Look, if you want to understand the liquid nature of a diamond, you have to stop thinking about solid as a permanent state of matter. In the world of classical physics, a solid is defined by its rigidity. But in the world of Leonard Susskind, everything is a phase in a much larger evolution. A diamond is a metastable state. It's like a car that is parked on a very steep hill with the parking brake pulled all the way up. It looks stationary, but it has a massive amount of potential energy that is trying to turn it into something else. Think about a glacier. If you stand in front of it for 5 minutes, it's a solid wall of ice. But if you set up a time-lapse camera for 50 years, you see it flowing down the valley like a river. A diamond is a glacier that takes 1 trillion years to move an inch. We call this structural relaxation. The grid of carbon atoms is constantly shifting in its sleep, trying to find a way to flatten out into graphite. It's a kinetic hibernation. You got to understand, this is a causal delay. We call this the Deborah number. It's a ratio between the time of observation and the time of flow. If you observe a diamond for a second, the number is infinite. It's a solid. But if you observe it for a googolplex of years, the number is 0. It's a liquid. We are living in a now where our lives are too short to see the rock move. We aren't just matter. We're a temporal snapshot of a process that is too slow for us to perceive. Why is this a liquid problem? Because it means that forever is just a statistical mirage. We've built our culture on the idea that diamonds are forever, but the universe knows better. The universe sees the flow that we can't. We are the ice that thinks it's eternal because we've never seen the spring. And we're just the ones holding the stone while the liquid inside is waiting for the timer to finally hit 0. You got to understand that if you take a diamond and crush it even further beyond the center of a planet and into the heart of a white dwarf star, the liquid loses its identity as carbon entirely. Under the weight of an entire sun, the atoms are packed so tightly that the electrons are stripped away. We call this electron degeneracy. The diamond doesn't just melt. it becomes a quantum fluid of pure nuclei floating in a sea of light. It's a solid that is so dense it behaves like a superfluid. Think about a jar of honey that has no friction. If you stir it, it will spin forever. In a diamond star, the carbon atoms are flowing with zero resistance. They are a Bose-Einstein condensate on a massive scale. The hardness we feel on Earth is just a surface tension that hasn't been crushed out yet. In the core of a star, the diamond is a kinetic ghost. It's a solid that can flow through itself. We call this quantum rigidity. Why is this a liquid problem? Because it means that the solid universe is just a low-pressure fluke. In the high-pressure reality of the cosmos, everything is a fluid. The only reason we have rocks is that the vacuum is too empty to squeeze us into our true form. We are living in a now where the glue is fighting a losing battle against the void. We aren't just matter, we're a dynamic standoff that is waiting for the gravity to win. Look, here is the real kicker. There is a star called BPM 37093 that is basically a diamond 10,000 kilometers wide. It's a solid the size of the Earth, but it's pulsating. It's ringing like a bell. That ringing is the flow of the internal liquid trying to find its balance. We aren't just matter, we're a universal vibration. We are the ice that is dreaming of being a wave. And, we're just the ones listening to the music before the star finally goes dark. Here is the real kicker. We've spent this whole time talking about the diamond as a liquid, but we haven't talked about the measurement. In the world of quantum mechanics, a system exists in a superposition of states. It's both a rock and a fluid until the universe forces an interaction. We are that interaction. Our existence on this planet, at this specific temperature and pressure, is the only thing that gives the solid its meaning. We call this the entropic phase. Think about a photograph of a waterfall. In the picture, the water is a frozen white curtain. It looks like a solid, but you know that if you press play, it will start to move. We are living in a photograph of carbon. We are a causal snapshot. The hardness of the diamond is just a high shutter speed illusion. If the music of the Big Bang were a trillion times slower, we'd see the diamonds splashing into the crust like raindrops. You gotta understand, this is the final equilibrium. The universe doesn't want order, it wants spread. It wants the carbon to be thin, flat, and cold. We are living in a now where the glue is still holding the ice together. We aren't just matter, we're a statistical miracle. We are the ice that has figured out how to build a civilization in the flash of a second before the melt begins. Why does this matter? Because a diamond is a solid lie that tells the truth about entropy. It's a temporary no in a universe that is screaming yes to disorder. Every time you look at that stone, you aren't just looking at a rock. You're looking at a kinetic rebellion. You're looking at a liquid that refused to flow just so it could catch the light of a star for you. And we're just the ones lucky enough to be standing here before the snapshot finally fades.